All right, let's get right into it. Today, we're going to tackle a topic that's, well, absolutely fundamental if you're serious about being a developer. Object-Oriented Programming, or OOP, specifically in Java. We're going to break it all down and show you how it can seriously level up not just your code, but your entire career.
So let's start with a big question, one that every single developer runs into eventually. How do you build something huge, something really complex, without it just collapsing into a giant, tangled mess of code? You know, as things get bigger, how do you keep it all organized and sane? Well, it turns out the answer isn't just about writing more code. It's about a whole different way of thinking.
And that way of thinking is what we call the object-oriented programming paradigm. Now, don't let the fancy name scare you. It's not just some dry academic concept. Think of it as a game plan, a strategy for organizing all that potential chaos by making our code look and feel a little more like the real world.
So what does that actually mean? Well, at its heart, OOP is all about one thing, creating these little bundles called objects. And each object is like its own self-contained little package. It holds two things: the stuff it knows, that's its data, and the stuff it can do, that's its behavior. And here's the kicker. Java is built on this idea from the ground up. So if you want to write clean, scalable Java apps, you've got to get this. Okay, so we're building things out of these objects. But where do they come from? How do you make one? Well, it all boils down to two key ideas that work together: classes and objects. Let's really dig into what that means. This right here is probably the best analogy you'll ever hear for this. A class is the blueprint for a house. It's the design, right? It's got all the details, number of rooms, where the windows go. But you can't live in a blueprint. An object, now that's the actual house. It's the real, tangible thing you built from that blueprint. And the cool part? You can take one blueprint and build a whole neighborhood of different houses, or, a ton of different objects from that single class. Okay, let's look at some code. This student class, that's our blueprint. We're laying out the rules. We're saying, hey, any student we ever create in our program is going to have a name, which is a string, an age, which is an integer, and it's going to know how to do something, like display info. This is just the template, the idea. There's no actual student here yet.
And boom, here's where we actually build the house. We take our student blueprint, and using that magic new keyword, we create a real living, breathing student object that we're calling S1. This is our instance, and then we give it its own unique details. For this student, S1.name is John and S1.age is 20. We've just brought our design to life.
All right, now that we get classes and objects, we're ready for the really cool part. OOP is built on what we call the 4 pillars. And I want you to forget thinking about these as boring textbook definitions. Seriously, think of them as your programming superpowers. They're what's going to make your code strong, flexible, and just better. Superpower number 1, encapsulation. The name sounds a little complicated, but the idea is simple. It's all about bundling an object's data, the stuff it knows, and its methods, the stuff it does, into one neat little package. And then you protect it. You put it in a protective capsule, so other parts of your code can't just mess with its internal data whenever they feel like it. So how do we do that? Take a look. See that private keyword in front of age? That's the lock on the capsule. It means nothing outside this class can directly touch the age. If you want to change or read the age, you have to go through these public doors we've created: setAge and getAge. This is huge. It gives you total control. You can add validation in setAge to make sure no one sets an age to like -5. It keeps your data safe and predictable. Okay, on to superpower number 2, inheritance. This one is a massive time saver. It's exactly what it sounds like. You can create a new class that inherits all the properties and methods from an existing one. It's all about code reuse and creating is-or relationships. Think of it like genetics for your code. A child class inherits traits from a parent class. Let me show you what that looks like. You might start with a really general parent class, like person. What does every person have? Well, a name. Simple enough. Then you can create a more specific child class, student. Now, a student is a person, right? So it makes perfect sense for the student class to inherit everything from person, like the name, and then add its own special stuff, like a student ID. And in Java, the magic word for this is extends. When you write class student extends person, you're telling Java to create that parent-child link. Instantly, your student class gets everything the person class has for free. You don't have to copy-paste the name field, it's just there. This is code reuse in its purest form, and it saves you so much time and helps prevent stupid mistakes.
Superpower number 3, and this one is a bit of a mind bender at first, Polymorphism. It's a Greek word that just means many forms, and what it means for our code is that we can have one method, one action, that behaves differently depending on which object is performing it. It's the shapeshifter of the OOP world, and it makes your code incredibly adaptable.
Here's a classic example. Let's say we have an animal class, and it has a method called sound. Now we create a dog class that extends animal. The dog can provide its own specific version of the sound method. We call this overriding. So when you tell a dog object to sound to, it prints dog barks. If you had a cat object that also overrode sounding, it would print cat meows. See? Same method name, sound, but totally different results based on the object. That's polymorphism.
And finally, our fourth superpower, abstraction. This one is your best friend when you're working on massive projects. Abstraction is the art of hiding complexity. You show only what's necessary and hide all the messy implementation details. The TV remote is the perfect real-world example. You just see buttons like power and volume. You don't need to know or care about the complex electronics inside that make it work. You just need to know what it does, not how.
And we do this in Java using the abstract keyword. Look at this vehicle class. It has an abstract method called move. Notice there's no code inside it? This is basically a contract. It says, I don't know how a vehicle moves, but I guarantee that any real vehicle, any concrete class that extends me, must provide its own way to move. So then, the car class comes along and provides the specific how. The engine, the wheels, all that messy detail is hidden inside the car's move method.
Okay, deep breath. We just went through the 4 big pillars, but here's the most important part. Why should you care? Why does any of this actually matter? Let's connect this theory directly to your job, your career, and your future as a developer.
Well, for starters, OOP lets you organize your code in a way that just makes sense. You get to reuse code with inheritance, which means you write less and build faster. It makes maintaining massive applications actually possible, because encapsulation and abstraction hide away the complexity. And maybe most importantly, it helps you work on a team, because everyone is speaking the same structured language.
And trust me, this isn't just stuff you learn for test and forget. These concepts are literally everywhere. We're talking big-time enterprise software, the back-end systems that power the internet, almost all Android development. It's all built on OOP. And here's the bottom line for a lot of you. This stuff will come up in your technical interviews, period. Knowing this code is one of the clearest paths to landing a job.
So really, getting a solid grip on these fundamentals isn't just the next step. It's the launching pad for your whole career in Java, and honestly, in software development in general. This is what separates messy, hobbyist code from professional, production-ready software.
And that really sums it all up, doesn't it? Understanding OOP isn't just a nice little skill to add to your resume. It is absolutely 100% essential if you want to succeed in a software engineering role. It's a non-negotiable.
So as you move forward from here, the real question isn't if you're going to learn these pillars, but which one you're going to tackle first. Are you going to dive deep into encapsulation to make your code more robust, or maybe start playing with inheritance to see how much code you can reuse? It's your journey. So which superpower will you master first?